We keep finding ourselves drawn to the same old question. Are we alone in the universe? But maybe we're asking the wrong questions entirely. Instead of searching for life, we should be asking, why are all the planets spheres? Why do they look like giant metallic domes? And what sculpted these massive structures? Is there an architect behind these celestial masterpieces? Turns out there is, and it's far more powerful than you might think. Buckle up, space cadets, because today we're about to uncover the ultimate architect of the cosmos. The images that have become iconic representations of planets and galaxies in our collective imagination are anything but random. Take a moment to really absorb the image of a planet. What do you see? A perfect sphere, a mesmerizing globe suspended in the vastness of space. Now let's zoom out a bit and marvel at the grander spectacle of a galaxy. What do we find there? A swirling vortex of stars and dust, also taking on a spherical shape. Now here's the intriguing part. These images aren't just pretty pictures. They're windows into a profound truth about our universe. Everything from the tiniest asteroid to the colossal galaxy cluster is a sphere. And this isn't a coincidence. There's a sculptor hard at work in the universe's workshop, patiently chiseling away until every piece of celestial matter takes on a spherical form. And now we want to ask, what is this cosmic artist? What force so powerful and pervasive that it has shaped the very essence of the universe? The answer, my friends, may surprise you. It's the force you feel every day, the one that keeps your feet firmly planted on the ground and makes apples fall from trees. You guessed it, gravity. But gravity, that's just a name. We don't know much about it. But what we do know is that without gravity, our world wouldn't exist. It's the invisible hand of the cosmos. It's been around since the beginning of time and will continue to shape the universe long after we're gone. When you take a step back and consider the true scale and impact of gravity, it becomes clear that this is no ordinary force. Gravity is the architect of the cosmos, the sculptor of spheres. This force has been meticulously turning shapeless cosmic dust into perfect spheres, creating the planets, stars, and galaxies that make up our universe. But how does this invisible force turn formless cosmic dust into perfect spheres? It all starts with the simple act of particles coming together. Imagine a single speck of dust floating in the vast expanse of space. On its own, it's insignificant. But everything starts somewhere. In the grand scheme of things, this tiny particle isn't particularly special, but it holds the potential for something extraordinary. As time goes by, another speck of dust drifts nearby. The two particles, drawn together by the invisible hand of gravity, begin to coalesce. At first, it's just a slight nudge, an imperceptible shift in their trajectories. But as time marches on, the gravitational embrace becomes stronger. The particles, once solitary and free, now find themselves bound together in a small clump, the first step in the creation of a celestial sphere. This process, known as accretion, is the foundation of how gravity sculpts our universe. As the clump grows, more and more dust particles are drawn into its gravitational embrace. The tiny sphere continues to accumulate mass, slowly becoming more dense and compact. But this isn't just a random collection of particles. It's the birth of a planet. And here's where gravity truly reveals its masterful touch. As the planet gains mass, the gravitational forces within it increase dramatically. The inward pull becomes a relentless force, squeezing and shaping the celestial body in ways both powerful and precise. But the young planet isn't just a passive recipient of this gravitational sculpting. It fights back, pushing outwards with the pressure generated by its internal heat. For a time, this internal pressure balances the inward pull of gravity. The planet, still in its formative years, remains somewhat lumpy, not quite the perfect sphere it will eventually become. However, as the planet continues to grow, the battle between gravity and internal pressure reaches a tipping point. Eventually, the inward pull of gravity becomes too strong to be resisted by the outward pressure. At this critical moment, something truly remarkable happens. The planet, under the relentless pressure of gravity, collapses in on itself, giving way to the most dramatic phase of its sculpting. The collapse is not a chaotic event, but rather a carefully orchestrated movement, a testament to the precision of the gravitational force. As the planet collapses, it simultaneously spins faster, conserving angular momentum, much like a figure skater pulling in their arms before a final spin. This spinning motion, combined with the gravitational forces, creates an almost magical transformation. The planet, once misshapen and imperfect, now begins to take on a spherical form. The material is distributed evenly around the center of mass, creating a near-perfect sphere. This state is known as hydrostatic equilibrium, and it is a delicate balance. If the planet were to collapse further, it would continue to spin faster, potentially flinging material off its surface and disrupting the spherical shape. On the other hand, if the planet were to expand, the gravitational forces would weaken, allowing the sphere to become more lopsided. However, in this perfect balance, gravity has achieved its masterpiece. The planet has been sculpted into a sphere. But the story doesn't end there. This principle of hydrostatic equilibrium is at play across the universe, shaping not only planets, but also moons and stars. Stars, like planets, start out as clumps of dust and gas. As they grow, gravity's relentless pull causes them to collapse. But for stars, this collapse is more dramatic. The immense pressure at the core generates temperatures hot enough to initiate nuclear fusion. The outward pressure of fusion reactions counteracts gravity's inward pull, creating a stable, luminous ball of plasma. This is how stars, like our sun, achieve their iconic spherical shape. Moons, too, follow the same path, albeit on a smaller scale. As chunks of rock and dust gather under the influence of gravity, they form irregular clumps. But as these clumps grow, gravity's inward pull forces them into a spherical shape. It's a cosmic dance as old as time, a never-ending performance of gravity's artistry. But the show doesn't stop at planets and stars. Gravity's reach extends far beyond individual celestial bodies. It weaves a grander narrative, shaping the very structure of galaxies. Imagine a vast expanse of space dotted with billions of stars. Each star, like our sun, is a luminous ball of plasma, a giver of light and life. But what brings these stars together? What holds them in their majestic formations? Again, the answer lies in the subtle yet powerful force of gravity. Every star in a galaxy has a story to tell, a tale of gravity's influence. They come together not by chance, but under the guidance of an invisible hand. Over billions of years, the stars have coalesced into a flat disk, a galactic disk, held together by their collective gravitational pull. Within this disk, the stars rotate, forming spiral arms that wind and curve in a mesmerizing display of celestial choreography. But the gravitational ballet doesn't end at the galactic disk. The stars, along with vast clouds of dust and gas, extend far beyond the visible disk in a massive, sprawling halo. This halo, a testament to the far reach of gravity, is a reservoir of the universe's raw materials, a nursery where new stars are born. And yet, despite the beauty and order of these structures, there is a constant state of flux. Stars are born and die, and their gravitational interactions leave their mark on the universe. Binary star systems, where two stars dance around a common center of mass, showcase the intricate ways in which gravity can shape celestial objects. Even in these intimate duets, gravity is the choreographer, dictating the stars' movements and occasionally shattering their forms. Simulations reveal the incredible power of gravity in action. Gravitational slingshots, where a celestial object uses the gravity of another to alter course, showcase the dynamic nature of this force. Tidal forces, which distort and reshape celestial bodies, offer a glimpse into the sometimes destructive capabilities of gravity. Yet through all these interactions, the sculptor's touch is evident. Even in the most dramatic displays of gravitational force, there is a sense of control, a precision that speaks to the masterful hand of the architect of the cosmos. From the smallest asteroid to the largest galaxy cluster, the prevalence of spherical forms is nothing short of astounding. And this isn't just a coincidence. It's a testament to the power and pervasiveness of gravity. It's a signature of the sculptor's touch. As we continue to explore the vast canvas of our universe, we'll undoubtedly uncover more examples of gravity's artistry. New worlds, new stars, and galaxies will reveal themselves, each a masterpiece sculpted by the invisible hand of the cosmos. So the next time you gaze up at the night sky, take a moment to appreciate the grand performance of the architect of the cosmos. Every sphere, every orbit, every gravitational interaction is a brushstroke in the grand masterpiece of the universe. And who knows? Maybe one day we'll discover that the architect has left clues to their identity, hidden in the very fabric of space-time. The question isn't just why are the planets round? It's who is the artist behind these celestial masterpieces? And the answer, my friends, is written in the stars.